Okay. We just want to continue from join. That is about that. Let us go to the comment section and we send the feedback very fast if we can be able to hear. Actually, before we start, we can see that indeed people are able to hear. But at the moment, you are most welcome. Even today, we want to proceed just like I promised. We shall look at item 2. I can so far see 4 people on. Others are still joining here. Are coming, so you should hurry so that we can start. Yes. Sorry for the for the intersection on the other side. We had some network problems for that particular case. Yeah, but at the moment, let me hope everything is fine. In the comment section, I'm not okay. We need to see. We need to make sure that this week, yes, that is good. Let us make sure that people are able to get information. Let us confirm whether you are able to hear. Okay, let us go where we go. Okay. All right. If you are able to hear, the teacher has already arrived, and I'm willing to go through what we are supposed to cover today. At the particular moment, I remain as Alexok as usual, your teacher, your chemistry teacher, YouTube teacher, at the same time physical teacher when we are at school. But as I sent messages, I promised you that we shall look at item 2. Now, the item 2 that we shall look at the major concepts, we shall look at some topics, because we are supposed to summarize some things like that. At the same time, when we are at home, we should not forget what we learned. So today, we want to look at item 2. Last time, don't forget what we looked at. We looked at item 5, 6. We also looked at 4 and 3, but in terms of social benefits and side effects of the process of production, we also looked at impacts of the natural resources and fuels. Then, when it comes to the environment, we also looked at importance of the natural resources. Today, we want to look at item 2 in particular. I said the lesson starts at 8:00 p.m. and it will end at 8:40, and we have started. But if at all we finish what we are supposed to cover very fast, even if we don't reach 8:40. So at this particular moment, since I can see people have already arrived, let us start. When you are at home and you are revising, take note of the following things in item 2. You have to know which topics are there. That's number 1. Then 2, on addition to the topics that you are supposed to know, let us also know the format of responding. Don't just respond. Let us know what we are supposed to write. As we know, when we talk about item 2, we are talking about category of the substance that we are interested in. At the same time, this category moves hand in hand with the reason that we are trying to talk about. Then, in the same way, we are after the category, we are supposed to know what we call the suitability of the product we are talking about, because in this case we are interested in products. That's why you find compounds, materials, you find there other substances such as elements. Most of these substances that we use in our life are made up of different chemical elements. So we have to talk about all those things. But at the end of it all here, if you know the category, it has know the properties, because the properties that make that substance that you have in the scenario, or else the one you are talking about, suitable for its particular function is. We should not forget that this one moves in hand with the users. Then also we have to remember that item 2, it can have calculation. Eh? That calculation part. Calculation. Then at the same time, item 2, we expect other things such as if we don't get a calculation, They can term in bonding and structure, formation of compounds. You can expect maybe formation of an anion compound, formation of a covalent compound, all those things. Now, when they have substituted what? The calculation. So all those things, formation of compounds, or how substances are formed. Then we need to know the dangers of those substances to the what? To the environment, or the challenges associated with those substances to the environment. If you try to look at all these things, we can take them in a summary, but they are broad as someone is revising, an interested person like you, if you are trying to revise. Those things that we can be able to see there are always handled when they are broad. So if we try to look at the category of the substance, we have to know, first of all, what are we talking about? These are the topics that we are supposed to put emphasis on. One, from senior one, where we looked at air, okay, let us start with materials, using materials. In the same way, just a reminder, we looked at air, we looked at mixtures, we looked at water. We have also other substances. In senior 2, we came and looked at the periodic table. Periodic table, which is made up of elements. Those elements, we introduced them from here, where we studied mixtures from. That's why we introduced elements from this one here, and also compounds. But as you proceed further, when you reach senior 3, you look at bonding and formation of compounds. That's when you bring bonding, ionic bonding, and covalent bonding. Okay, that is not a major case. So in the periodic table, what we are interested in are the trends in terms of the reactions, and also when we talk about those elements in particular, the metals and the non-metals as far as their categories talked about. Then in the same way, if you leave the periodic table, we also have acids and bases. Acids and bases. Please, we also have bonding and structure. We have oxidation and reduction. There are some like trends in periodic properties, those ones that you looked at already, trends in periodic properties, senior 4 work. When you look at this one, we have carbon in life, where we have compounds such as carboxylic acids, alcohols, alkanes, alkenes. Those ones that we normally look at. Alkenes, carboxylic acids. Okay, let us say carbon in life. Those ones, and very many other compounds, but very many other topics. But in this case, we are talking about the major ones. So let us see. We said we are in item 2, and in this case, item 2, the major part, category. Then after the category, you give us the reason. Then after that, we need to know the properties and the uses. Now, these properties and uses are the ones that we normally talk about in terms of suitability. When someone says suitability of the product, the scenarios brought the product. There are times whereby those examples are talked about in the scenarios, then at times they are not mentioned, the scenarios. So as a person who learned chemistry, you understood everything, and you people, I trust you, you understood everything. Now, after understanding everything, you can be able to come and interpret what they are trying to talk about. The scenario will be in the English that you always understand. Now, the simple English that you understand, you can be able to read and you identify that product that they are trying to talk about. And you see, there are times whereby the example you are supposed to categorize is in the scenario, and then there are times whereby it is not there. But if the scenario is supposed to be developed, then the scenario will bring out the purpose that we're interested in. If it is in construction, someone here talk about what you're constructing. It can be constructing the wall, it can be roofing, and you have to know which materials we use in roofing. It can be making a chair, any. and for any particular function. It can be making clothes, so any purpose can guide you on the material to select. Someone may be interested in selecting a better material, provided you've been given another material in the scenario, and they are talking about it, uh, that it is not that it cannot it is not, it is of poor qualities, and therefore they are interested in a better material that can work very well. So you have to give the example in that case, and then after, what happens is you follow the question. We are supposed to follow parts that are always put there. We are supposed to follow the examiner. What have you been told? Don't You should not wizard. For example, if the examiner is asking for the category, give the category. But you have to give us the reason. That one shows broader understanding of the concept. Then also properties and uses. Now, what we can also combine this one here, and instead of properties and uses, we just have suitability. That one alone. Then we can also combine this one, and we call it there are times whereby we are calculating which parts are you supposed to calculate. We can calculate masses. If at all we are using an equation, just like you covered them in the topics you learned. You can calculate masses, you can calculate moles, you can calculate volume occupied by a gas, either at room temperature or at standard temperatures and the pressure, STP. The constants that we were supposed to use, you have to know them, but also they are always, if they are not on the front page of the paper, you have to read it very well. That's why we advise someone that at least make sure that you read instructions. Someone sitting for rush, you want to see what is inside, and yet you've not understood. One day you'll be given a paper which has the following instructions: do not attempt anything in this paper. And before you rush to open, now when you open, what happens is you write whatever you to make a matter as well. When everything there, you know it, you write, you move out and even put the leg up. You see, I've beaten it, and yet it has squeezed you because you never read instructions. You can look at people sleeping. You say, I'm the only person who read. I'm the only person who revised before entering the paper. And yet you were fooled because you didn't read instructions. Your friends already read instructions, and they are writing what they read. They are sleeping because that's what the paper is telling them. Do not attempt anything in this paper. So for that matter, we have to read the instructions always, and always on the front page of the paper, you can find there some information to use, either atomic masses, maybe carbon equals 12, oxygen equals 16 to use, or else you can find there the molar gas volumes. 1 mole of a gas at STP occupies either 24,000, so it can occupy maybe 22.4 decimeters cubed. That is at STP. So you have to read and you find out which information is on the page of the paper. So that's what we have. Then the dangers, as usual, we are supposed to give dangers in respect to the what? The environment. So these are dangers. If it is a substance, there are some that are biodegradable, and those ones, normally we don't over talk about them in terms of soil infertility. Normally talk about those ones that are non-biodegradable when we're talking about the danger of soil infertility and low crop yields. And we have to give the appropriate mitigation for that particular case. Okay? Now, other things can be okay, like if you are talking about materials, the materials can be construction materials. They can be construction materials or they can be polymers. So we have those ones that are metallic, normally those ones that are used for construction. Others like iron bars, we have iron sheets, we have the bricks, and the others. Now those ones are others are not polymers. But now when we talk about polymers, cotton, polyester, we have natural polymers and synthetic polymers. Synthetic polymers are the ones that are just made by man. You synthesize them. Then natural polymers, those are the ones that are made by God. They exist naturally. And you have to know the examples. Cotton is one of them. Rubber depends. It depends whether it is synthetic or natural. It depends on what was used to make it. But always the one we get from latex trees, that one is always natural rubber. We just improve the properties and becomes vulcanized rubber when we hit it with sulfur. But at the end of it, or even when we hit it with sulfur and we form vulcanized rubber, it remains natural because we just improve on its properties. We don't synthesize it. So it remains natural rubber. That's vulcanized rubber. But we also have synthetic rubber. And we have to look at all those properties. Now, when we are talking about using materials, when someone is answering this part, the most important thing is properties and uses. These parts are combined together. Now, when they are combined together and you forget one, either you don't write any correct property or you don't write any correct use, then that will mean that you are going off. There are times whereby people proceed and instead of writing any other use, for you use the use which was used to come up with the scenario. You want correct simple things. You write the use which was already in the scenario. No one marks the use which is already in the scenario. We want any other use. That's what we are interested in. We are interested in any other use. That's what we want. Interested in any other use. Therefore, and you follow the English. If the question is saying uses, give uses. Uses means the plural form. I'm getting challenges. I'm marking some people's exams. Now, when you are trying to mark someone's paper in the practicals and they have asked for receipts, but people have maliciously refused to write receipts. They are writing receipt. Someone is asking for receipts, meaning at least two correct receipts. Two correct receipts well mitigated, but still someone writes one receipt. But when it is very clear receipts, when we are answering, we follow the English. And in this item particularly, let us give it time. When they say any other use, even if you write one, you get the mark. But if they say uses, then it means that we are interested in what? In two. Those are the ones that we are interested in, two. So you have to give it time when you are trying to talk about this one. Uses, at least make sure that you have to, and not those ones in the scenario. Okay? We have challenges sometimes with carbon dioxide. If someone is saying something about carbon dioxide and limits you by talking about carbon dioxide being used in fire extinguishers, it is used in fire extinguishers. Now, when you ask someone other uses of carbon dioxide, again, someone says with fire, you can see we are saying the other uses, not the one that is already in the scenario. And if you put that one which is already in the scenario, it is the correct use, but wrong in that case. So we have to correct that. Then the calculation that most of you say they are hard. Hard calculation is hard. No. Sit down and look at the topic. What do we have to know? One, RFM. I already uploaded the videos about RFM. They are there. So long as you have the information for those atoms, sodium, calcium. Calcium is 40, sodium is 11. Everything can be easy. Then many of us look at this and he said that I cannot relate the equation. The equation which is given to it is already well balanced. You have to just look at those values that they have used for balance, the one we call stoichiometric values. Use them for relating 2 moles of this one produced. What about this? Know how to convert just from mass to moles and back from moles to mass. From moles getting mass. Then after, know how to calculate the volume. 1 mole of a gas contains what? What about this? Then another thing, know how to get empirical formula. Empirical formula, because there are times whereby if you don't know the empirical formula and you don't know how to get the molecular formula, you have to know the molecular formula and you know maybe if it is a compound, what are you going to categorize? There are times whereby this part comes before the category. Why? You have to first look for the formula. That's when you can know the compound you are dealing with. If it is unknown in the scenario, then after knowing that compound, you come and categorize it. Now, after categorizing, you can be able to give the reason. But when you have known the compound, Meaning, we have to know how to calculate empirical formula, molecular formula. When we are there, let us try to practice these things. We have to know how to calculate empirical formula, molecular formula. As you calculate empirical formula and molecular formula, when maybe you are using the masses provided for those elements, maybe when you are using the percentages. And then you have to know how to relate them, the molecular mass of that compound, such that you can be able to get the molecular formula at the end, such that you can be able to categorize. The rest of the things, okay, let us see, summarize on the categories that we always have. Someone can ask a reason why we have written all of these things. When you talk about this one, we have polymers, but materials are categorized into two. There are those that are made by man, and then there are those ones that are naturally made. For example, we normally say that materials are synthetic or natural. Those are the two categories that we're talking about. Synthetic materials because they are made by man. Synthetic means manufacturing something through different steps. So synthetic materials, spelling synthetic. Then there are those ones that are natural, made by God. That is the reason that we are trying to give natural material, because it's made by God. Now, you have to upgrade a little bit. If it is a polymer, tell the person synthetic polymer, natural polymer. Most especially when we're talking about shoes. I want to make a shoe soles. Now there I'm going for maybe vulcanized rubber, natural polymer. So you have to, if you are talking about polyester, those synthetic polymers, then you have to know their dangers. All the polymers, synthetic polymers are non-biodegradable. They are poor disposal into the environment, prevent saturation of water into the soil, and at the same time, they lead to soil infertility after some period of time, which leads to low crop yields. That one is okay. But the best way of mitigating that, recycling, because some of these polymers can be recycled. Recycling. Talk about poor disposal. If you are telling us where are we going to dispose, garbage dumps, landfills, just in case. And what are we disposing? The used materials. So disposing the used materials of maybe polyester, simple as that. We don't just say poor disposal. Where are we going to dispose? You have to direct us. Then why are we included here air? We have included here air because in air it's studied about rusting. Interaction of iron with oxygen and water, that is rusting, to form a reddish brown coating of hydrated iron 3 oxide. Reddish brown. Try to leave your hole. You are at home. Leave the hole outside. For how many days? Since you were a chemist, we don't expect these answers. I was not there. Since you were a chemist, try it out. Since you're at home, get your hole. There are many of those people. Some other people have pangas at home. Leave it outside. For once, it will not be destroyed. You see what really are we talking about? Because at least for it is clear and can easily interact with that oxygen and what? And water or moisture when it is outside. So it forms the reddish brown color. That's what us. Now, interaction of materials. Everything we read here talks about interacting of substances with the environment. That's why we're talking about this. When you leave air, now when the iron is interact, that is rusting already. There is combustion in the air because oxygen is used for what? For this case. For example, if someone gives you an equation, carbon reacting with oxygen to form carbon dioxide gas. Now, this one has been developed. And at the same time, maybe someone either asks for the category of the gaseous product or the product formed, or else the solid reactant. So you have to know, in that case, which kind. This one is an element, and then this one is a compound. And that's why for this particular case, now we come to water. Water itself, water which is H2O. We even know its properties. But since we looked at compounds, we know that water is as a result of covalent compounds. So we can be able to categorize that water, but also the properties are very clear. Water is neutral to litmus paper. That's in case we're talking about pure water. Neutral to litmus paper. Colorless liquid at room temperature has a boiling point. Pure water has a boiling point of 100 degrees Celsius. Pure water has a high specific heat capacity. We are giving properties of water. Now you've been given such a scenario, and someone has told you to categorize water. Then at the same time, maybe they have talked about the uses of water. Maybe it is used in your car radiators, and you are expected to give the suitability of water. Meaning you give us other uses of water and also properties of water that make it suitable for that particular function. Now that's when we come. 1, water is neutral. Pure water is neutral to litmus paper, both blue and red. 2, we are talking about pure water having a boiling point of 100 degrees Celsius. Pure water is a colorless liquid at room temperature. Pure water has a high specific capacity. We are giving those properties. So anything you can. Now mixtures, we have those ones that are homogeneous. We have homogeneous mixtures and heterogeneous mixtures. We are talking about categories, such that you can be able to know homogeneous mixtures and heterogeneous mixtures. Homogeneous mixtures form one uniform layer. Then all form a uniform layer. When you mix the two, for example, if you get water, mix it with ethanol, they form a uniform layer. You don't know that this is ethanol, this is water. But if you get paraffin and water, you mix them together, they form distinct layers. Now those ones, now such a mixture where we are forming distinct layers, the one we refer to as a heterogeneous mixture. And you have to give attention to that. We have elements, the ones that we normally talk about when we reach a periodic table in details, that are divided into 3. We have metals, nonmetals, and metalloids. But the ones that we normally look at are the metals and nonmetals. Metals and nonmetals. So those are the elements. So when we talk about the periodic table, we are interested in those elements and categories of elements. Elements are divided into 2. In summary, elements, we are saying that these ones, we have, okay, let us leave out the metalloids. We are talking about metals and those ones are non-metals. So we have left out the metalloids. We have metals and non-metals. Now, when you give someone, for example, if we have sodium, that is sodium, and we are supposed to categorize sodium, you have seen that maybe, or you already know that maybe the atomic number of element X, or someone gives you X, and then it gives you 11 here, then it gives you maybe 23 here. The atomic number is the one which is down, and the atomic number is the one that you are going to use to write the electronic configuration. For example, what's the electronic configuration of this element X? It becomes 2 to 8 to what? 1. Now, when it has 2 to 8 to 1, it has an electronic configuration of 2 to 8 to 1, and for that particular case, it has 1 electron on the outermost energy level. Now, if it has 1 electron on the outermost energy level, this one here, it loses that 1 electron. Now, as it loses that 1 electron to form a stable electronic configuration. Now, the stable electronic configuration that we shall form after will be 2 to 8. That's the one we are having. Now, which electron has been lost? The electron which is on the outermost energy level, and electrons which are on the outermost energy level, we normally call them valence electrons. Valence electrons are the ones that are always found on the outermost energy. We are saying valence. Valence electrons. Not valence with Y. Valence with Y now means a combining power. For example, sodium has a valence of 1. But now this the valence electrons, we are writing this one. So valence electrons. Now the valence electrons, Sodium has only one valence electron, and the one which is lost. So any metal atom, for example, may be calcium. So for calcium, the atomic number of calcium is 20. So the electronic configuration of calcium for this particular case becomes 2 to 8 to 8 to 2. So the first energy level has 2 electrons, the second one has 8 electrons, 8 electrons, the third one, and then the last one has 2 electrons. So calcium atom has 2 valence electrons. So when it is bonding, it has to lose all of those electrons. And when it is reacting, it has to lose all of those electrons, the ones we are calling valence electrons. That's why when we are giving the reason for calcium to be a metal or sodium to be a metal, we are going to say sodium is a metal because it reacts by, or sodium is a metal because its atoms react by completely losing, or by losing its valence electrons. By losing its valence electron. Now, since you know that it is sodium, every sodium atom has one valence electron. So we shall say that sodium is a metal because it is an atom. If you are saying atom, its atom reacts by losing one electron or one valence electron. By saying one valence electron, you have clearly talked about that the electron which is being lost is the electron on the outermost energy level. Let us try to be specific. So reacts by losing its valence electron, or reacts by losing one valence electron. But if you don't know the number of electrons, then you better say valence electrons than creating problems on problems. So this is what we are having. So calcium, for the calcium is a metal because its atom reacts by losing 2 valence electrons, or by losing its valence electrons to form a cation. Its atom reacts by losing its valence electron to form a cation, or a positively charged ion with a stable electronic configuration. That's when it is a metal. And the reverse is true when talk about the nanometal. Because now the nanometal like a chlorine, nanometal like oxygen, those ones normally react by, the atoms react by gaining electrons to form stable electronic configurations, or to form negatively charged ions with stable electronic configurations, gaining electrons. Now, after knowing the elements, we have to know that for them, when you are trying to talk about their properties, you are going to, it depends whether you know the element or not, because there are some properties when they are for metals, but they don't work on each and every metal. There are some properties that are for nanometals, but when they don't work on each and every nanometal. For example, we are saying that nanometals can be gases, can be solids, or they can be liquids at room temperature. That is correct. And now for the scenario, it has specified the metal, and is what is chlorine. You don't also write like that, like they have written in the books. That nanometals can be. Now you have to be specific in that case. Since it is chlorine, for it is a gas at room temperature. So that's what we are trying to talk about. Okay. So when you are giving the properties of metals, you have to explain. For example, if I'm talking about calcium, I'm talking about iron, why are they having high melting points? You have to give us the reason. Normally we say metals have high melting points, but when you are rating, you're not supposed to metals. You have to be very specific, that element. If element X is iron, and you have known that indeed element X is what? Is iron. Then be specific and say X has a high melting point. Don't say metals. Find the category is a metal, and we are going to say that X is a metal because it reacts by losing, or its atoms react by losing a valence electrons to form positively charged ions with stable electronic configuration. That is okay. Then when you come to the point of properties, you are going to say X has a high melting point because maybe its particles are closely what? Packed. The particles are held together by strong electrostatic forces of attraction. 2, we are saying that maybe X has a high melting point, and the same reason X is a solid at room temperature. The same reason particles are closely packed, and therefore they occupy a smaller volume. Many particles occupy a smaller volume. That's in case we are talking about high density. And the reason why metals have high density. So X has a high density because the particles are closely packed, and therefore they occupy a smaller volume. So when you say X is a solid at room temperature, still particles are closely packed. And we are trying to break those ones. Then when you are giving the reason, now find out iron is used in very many aspects. Being used for making iron sheets. Since it is a metal, it can be used for making barrels. Because when it's struck, it produces a deep ringing sound. That is already a property. When it's struck, metals have shiny surface, and iron also has a shiny surface. Now you go and give out the reasons depending on the properties. That's why we talk about suitability. I want to leave elements at the moment. I'm just reminding you, but all metals are non-biodegradable and some non-metals are non-biodegradable. Those ones that are solids at room temperature are non-biodegradable. Today, I just wanted to, okay, I will end with this one, bonding and structure, just to summarize the properties about compounds. Allow me first talk about this one slowly, oxidation and reduction. Now, in oxidation and reduction, we have some characteristics that are the oxidation numbers, oxidation state. So instead of someone giving you the part of calculate volume, you can be taught to calculate oxidation state, because that one is also a calculative part which you look at. You've been given an iron complex, and you were supposed to calculate the oxidation state or a compound of an element. Let's check those things that are in the book. So this one, at the same time, since here we studied about cells, electrolysis in this part. Now we can be interested on what is being formed at the cathode and what is being formed at the anode, the category. There are times whereby you are in electrolysis and you are purifying copper. But now copper is being deposited at the cathode. So now that brown substance at the cathode categorize it. So you have to know that it is copper, and therefore it is a metal. And you give the reason, properties of the copper. I think it is one of the metals that has a unique property. Okay? There are something that we forgot here. Under the activity series, and we forgot to write alloys. Alloys, very important concept in item 2. Alloys. They have all areas that you can be able to find an item in suitable areas of chemistry. The chemistry is here. Item 2 has a lot of chemistry that you have to revise and you really enjoy. And most especially when you are supposed to continue with chemistry. Item 2 is very important. Because now there's something that we just look at and we understand them. But this chemistry you have to move with it. So oxidation and reduction, you give it attention. In that particular case, you have to know what is formed at the cathode, and you have to know which elements. That's like that you can be able to categorize it. When you look at acids and bases, you just have to know if something is an acid depending on the definition of an acid. An acid is a substance when dissolved, maybe when in solution form, releases hydrogen ions as the only positively charged ion is. That is an acid. For the base, it releases hydroxide ions are the only negatively charged ions in solution. That is now a base or an alkali. But now, you can relate it in terms of pH. pH. Those ones that have pH of 7, they are neutral. They are neither acids nor alkali. Normally, pure water is taken to have a pH. Pure water, I'm talking about pure water, pH of 7. But now when it has some impurities of acids, it makes it to be either having a pH of below 7 or above 7 if it has impurities of alkalis. Okay, now if the pH is below 7, then that one is an acid. So it depends on how the scenarios come. Now, all in all, you have to know that it is an acid because when dissolved in water releases hydrogen ions as the only positively charged ions. And the other side, for bases, we talk about hydroxide ions, just like the way how we look at those meanings. Give attention. You give this one attention. But now when you come to, as you are revising, when you come to carbon life, we look at alkanes. Alkanes have carbon single bonds and the functional groups. So alkanes have carbon single bonds and carbon hydrogen bonds. It has two functional groups: carbon single bonds and carbon hydrogen bond. Okay? Talk about carbon hydrogen bond and then carbon single bond. Those are alkanes. Then alkenes, for them, we are saying that they have carbon double bond as the functional group. Those are alkenes. Then alkanes, let us ignore alkanes a little bit. Alcohols, they have hydroxyl group. That's the hydroxyl group. When you are writing the word, it is the hydroxyl group, this one here. Now the hydroxyl group, it becomes the functional group. Now for you, when you are giving the category, some of these compounds, organic compounds, because in carbon life we are looking at organic compounds, they are called organic compounds. Now these organic compounds, the alkane, alkene, the alcohols, and also carboxylic acids, we are having what we are calling carboxylic acids. Carboxylic acids. Now the carboxylic acids, what do we know about carboxylic acids? For carboxylic acids, they have this one here. We call it the carboxyl group. Carboxyl group and the functional group. Now, any carboxylic acid ends with this one. An example is ethanoic acid. That is ethanoic acid. Now, when you look at that ethanoic acid, if you try to look at some of those items that you have, and also some of the question paper, one of them is the ethanoic acid. So you have to look at it very well. Now, if you have such a compound, first of all, it is made up of nanometals, so it can be covalent. But also, it is found under a certain family of organic compounds, the one we call homologous cell. So that's the one we are calling carboxylic acid. So this compound is a carboxylic acid because it has the carboxyl group as the functional group. So that is the reason in that case, and it is under carbon in life. That's what we are trying to have, under carbon in life, and we have to give it attention when we are looking at it. Now, when you are in a carbon life, you expect alcohols, ethanol. You looked at ethanol, and even looked at properties of ethanol. You burning test all those properties, careless liquid at room temperature. So you looked at the properties of ethanol, and we even looked at uses of ethanol. We even looked at dangers of ethanol, abusing ethanol. So we should do, now since we're in chemistry, we should avoid those answers. Uses of ethanol, we take it to pass time. What about you who is under, what about you, you people who are under 18 years? Do you also take it to pass time? So that one should be an issue to be addressed. So when we are talking about uses of ethanol, yeah, you have ever, in COVID-19, we suffered a lot, and ethanol performed some work. Sanitizers, that's number one. Sanitizers, thank you, sanitizer. So it is used as a disinfectant. It's responsible for killing some germs and all other uses. Since when it has a burning test, it can be used as a fuel. Many of these alcohol can be used for making spirits, as you can be able to sit down and read about them. So you have to know alkanes, you have to know alkenes, and you have to know alcohols. At the same time, you have to know carboxylic acid. And their reason is alcohols have hydroxyl group. I'm here to talk about the categories. Then maybe when we meet last time, when we meet next time, we shall be able to talk about other parts, maybe the dangers in details. But today let us clarify on the categories. So carboxylic acids with hydroxyl group are the functional group. Alcohols, hydroxyl group as the functional group. Alkanes, they have carbon single bonds and carbon hydrogen bonds at the functional groups. Then alkenes, for them they have carbon double bonds. Alkanes have carbon single bonds and carbon hydrogen bonds. Then alkenes have carbon double bonds at the functional groups. Give attention. Then alloys are just mixtures of two or more elements. Give them attention. The reason why elements are mixed to come up with the alloys, so it's only one that when we mix these elements or substances to come up with alloys, what happens is we improve on the properties, and the properties of alloys will be somehow different from the properties. We have improved the properties. Any alloy is taken to be stronger than a pure metal. Any alloy will be more durable than a pure metal. That's why when you find some knives, maybe you find stainless steel, meaning it is a mixture of elements, not only one element. There are times whereby we come up with alloys because at the end of it all, we prevent the material from over interacting with the outside air or environment. Interacting with the environment, we prevent rusting in such cases, and we increase on we increase on the strength of such a metal. Even the melting point increases, and all other properties. So when we are comparing pure metals and alloys, we just use comparative language. More durable than this. Alloys are more durable than pure metals. But all in all, when someone has given you a material and it is an alloy, its property rotates around. It is category rotates around the alloy. Brass is an alloy, simple as that. If it is iron, then iron is a metal. But now brass is an alloy. And the reason is very clear, it is a mixture of two metals. And you have to know those metals. You have to know how many elements are mixed. You have to know how many elements are mixed to come up with that alloy. If you set two elements or two metals, and yet part of those elements we are talking about, there is another metal, for example, carbon, then you are wrong. If you say it is an alloy because it is a mixture of four elements, and yet they are two, you are wrong. So you have to read alloys: bronze, brass, stainless steel, hard steel, duralumin, among others. You have to read them. And you know they are made up of what, and better enough, we have to sit down and revise. So those are alloys. Now, I just wanted to end with bonding and structure. Bonding, which is divided into majorly four. We have ionic bonding, we have covalent bonding, we have dative bonding, and we also have metallic bonding. Now, the ones that we normally give attention in terms of formation of compounds, we normally look at the ionic compounds and covalent compounds. So covalent compounds are as a result of covalent bonding, and then ionic compounds are as a result of ionic bonding. Now, if we talk about ionic bonding, we talk about a metal atom and a non-metal atom. Why? Now, the non-metal atom, since we have looked at a metal here, a metal atom reacting by losing an electron. For example, since I've maybe removed all of these things here. And since I'm ending with this, we are talking about an example is calcium oxide. So that's calcium oxide. And if you talk about calcium oxide, it has a calcium, which is a metal atom. And then it has oxygen, which is a non-metal atom. Now, the non-metal atom or non-metal atoms gain electrons from the metal atoms. So the metal atom is going to lose its valence electrons, and those valence electrons are going to be gained by the non-metal atom. So when we are talking about this one, the metal atom which is going to lose electrons is going to become a cation. And since calcium has the electronic configuration 2 to 8 to 8 to 2, it loses these valence electrons, and therefore it becomes positive charge with a charge of positive 2 since it loses 2 electrons. Then oxygen, electronic configuration 2 to 6, atomic number 8, it gains 2 electrons to become negatively charged with a charge of negative 2. Now, where is the oxygen going to get the 2 electrons that it will gain form a stable electronic configuration at the end? This one, because after this one gaining, it forms 2 to 8. Now, after this one also gaining, losing, it forms 2 to 8 to 8. Those are the ones we have. But now, where is this one here going to get the electrons? It is going to get electrons from calcium atom. And the rest electron by calcium, the rest electron is by calcium, again by the oxygen atom. When we are talking about this one, we are forming positively charged ions and negatively charged ions. Now, the positively charged ion and the negatively charged ion are the one that attract one another. And the force of attraction in that case to form a compound that we are calling calcium oxide is the one we are calling electrostatic force of attraction. So that's what the electrostatic force of attraction between the oppositely charged ion is. That's the ionic bond. And now it is the ionic bond is leading to the formation of ionic compound, which is calcium oxide. So when we are giving the category of this one, we are saying calcium oxide is an ionic compound. Is an ionic compound. But why is it an ionic compound? Because it involves complete transfer of valence electrons. I've added the word valence. Complete, all of them. Valence. If you say complete transfer of electrons, it means that you are meaning all of the electrons that calcium has. Complete transfer of electrons. But if you say complete transfer of valence electrons, then you are only meaning these electrons on the outermost energy level, and that's the correct thing. Complete transfer of valence electrons, these ones here, to a non-metal atom. We are saying calcium oxide is an ionic compound because it is formed by complete transfer of valence electrons from calcium atom. I'm repeating, calcium oxide is an ionic compound because it is formed by complete transfer of valence electrons from calcium atom to oxygen atom. And that's what we are trying to talk about. So that's the ionic compound. So at the end of it all, the ionic compound forms positively charged ions and negatively charged ions. Then when it comes to covalent compound, for example, carbon dioxide, the covalent compound is formed from non-metal atoms. Non-metal atoms. So the reason why it is a covalent compound because it is formed by mutual sharing of electrons between non-metal atoms. Mutual sharing of electrons between non-metal atoms. And there are very many other covalent compounds. For example, hydrogen chloride. Another one, we have water itself. They are there. Another one is carbon monoxide. Carbon monoxide. So they are formed by mutual sharing of valence electrons between non-metal atoms. We added non-metal atoms. So we have carbon atoms and the oxygen atoms. So each atom brings the same number of electrons to be shared, and they share them equally. That's what we are trying to talk about. So at this particular moment, maybe when we meet next time, we shall continue from there. I know the comment section has something to answer, which, as I promised, we normally answer after the lesson, and we are about to answer that. Maybe when we meet next time, we shall talk about other areas that we shall give attention. Let us end there for today. I wish you the best.